Section 5.4, solving logarithmic equation and exponential equation. So in previous section, like section 5.3, we did one example where we solve logarithmic equation. Here we're going to do more. uh, while solving the exponential equation, this property is very useful. A to the power x equal a to the power y. If you have the same base on both sides, then this is very popular property we can use for solving exponential equation. But if you have different base, or if you don't have the same base, for example, if you have a to the power x equal, let's say, k, so we don't have different same base, and let's say there is no way we can express k as a to the power something, then to solve this kind of equation, we can always go from exponential equation to log equation. So we can take, you know, ln both side, and that equation, that equation uh, can be changed to this form, and by using the power property we can bring this x in front, and finally eventually the answer, the x would be ln k over ln a. So that would be our answer if we have no way to express the right side as a to the power something. Okay, and then if we are solving log equation, this is the property we already used in section 5.3. We're going to use this property one more time. So let's do one example. 3 to the power 7 equal 3 to the power x equals 7. There is no way we can express 7 as a 3 to the power something. So let's take ln both side. If 3 to the power 7 is equal to 3 to the power x is equal to 7, then ln of 3 to the power x is equal to ln of 7. Okay, it's like if x is equal to y, then ln of x is equal to ln of y. We can write it down. So now we can use the power property and we can bring this x here in front. So now to find out x, we just divide both sides by ln of 3. So x is ln of 7 over ln of 3. So based on what form of answer you would like, if you like your answer in decimal form, then you have to use your calculator. Type ln 7 over ln 3, and then that will give you your answer. If you want exact answer, then just type it as is, ln 7 over ln of 3. Just write it down, your answer as is. Okay, so that's your final answer. But remember one more time, if you want your answer in decimal form, you need to use a calculator. Here in this problem, there is a 4 on the base on the left side, and there is a 16 on the right side, but there is a way we can express this 16 as a 4 square. So a to the power x equal a to the power y. That is only possible if the exponent value are equal. So because there is a same base 4 and 4, so we can write it down as x squared plus x equal 2. So this is quadratic equation. We can bring this 2 on the left side and we can solve this. For solving this, we can use factoring method, we can use quadratic formula. Okay, so here what we can do, it's 2 minus 1, 2 minus 1, so x squared x plus 2 x minus 1. Is that right? Okay, x squared 2x minus 2, yeah, that's right. So x is equal to negative 2 and x equal to positive 1. So these are the two possible solutions for this equation. If you put 1, that will be 16. If you put negative 2, that will be again 16. So these are the two possible solutions. So this problem is very similar to the to a problem we did in previous section, but we need to use a property of log function here more than once. So this is the one property we have, log base a of x is equal to log base a of y. If you have this situation, then you can write down x equal to y. but there are two logs on the left side. And to combine this log, first of all, we bring this 2 on the exponent by using the power rule. But remember, whenever you try to solve log equation, you need to find out the domain of that equation first. So from the first log function, you can see that 5 minus x has to be greater than 0. That means x has to be less than 5. And for the second and third, log function, there is no variable. So the domain of your function is anything less than 5. So if you, after solving this equation, if your answer is from here, then you can accept that answer. So first of all, use the power property, which is log base 5, 5 minus x whole square minus log base 5, 2 equal log base 5, 18. And now, because there is a negative sign, you can use the quotient rule, which is log base 5, 5 minus x whole square over 2 equal log base 5, 18. Because they have the same log function with the same base, so we can just cancel this log function, and we can write down 5 minus x whole square over 2 equal 18. So 2 times 18 is 36. Okay, so I can write it down this as a 5 minus x whole square equal 36. And now by using the square root property, 5 minus x is equal to positive 6. And we can write, because if you take the square root, 5 minus x has to be square root of 36 plus and minus the square root of 36, which is positive 6. That's one of the option. And 5 minus x, 5 minus x could be negative 6. Okay, so if you solve the first one, so just subtract 5. So negative x equal positive 1, x equal negative 1. That's the first option. Subtract 5. So negative x equal negative 11, x equal positive 11. So these are the two options. These are the two solution, possible solution, potential solution. But if you look at the domain has to be less than 5. The solution has to be less than 5. So we cannot accept this second solution. The only solution that's possible is negative 1. Okay. Let's look at one more problem. Solve the logarithmic equation. There is a log function on the left side. There is nothing. There is no log function on the right side. So we can go from log to exponential function to solve this. Okay. So we can write it down this as a 3x minus 7 equal 4 to the power 3. If you remember this property, log base a of x equal y, which is equivalent to a to the power y equal x. So x is 3x minus 7, base is 4, and then y is 3. So 3x minus 7 equal 4 to the power 3. Remember, one more time, before solving this equation, you need to find out the domain of your log function. So you have to make this expression, this thing greater than 0. So 3x greater than 7, x is greater than 7 over 3. So the domain, the solutions has to be greater than 7 over 3. So let's try to solve this one. Just add 7 both sides. So 3x equal 4 times 4 times 4, which is 64 plus 7 is 71. So if you divide both sides by 3, x is 71 over 3. So that's your answer, and that is definitely from this domain, so you can accept this answer. Okay, one more problem. Using the log property, first of all, on the left side there are two log function, on the right side there is none. So first of all, try to combine the log function, but before that, find the domain. For finding the domain, whatever you have inside this parenthesis, make it greater than 0. So that gives you x greater than negative 2 over 5. That's the first thing. From the second one, x has to be greater than 3. So we are going to find, we are going to take the intersection of these two, which is definitely, x is greater than 3, because the first one is x is greater than negative 2 over 5. Second one is x is greater than 3. So intersection would be this one. So the domain of this function we're using here, the domain is anything greater than 3, which is 3 to the infinity. So now after that, we can combine this log function on the left side by using quotient rule, and then there is a 2. So now we can use a log property, equivalent property. So that is log base b of x y is equivalent to b to the power y equal x, or x equal, x means this thing, 5x plus 2 over x minus 3 equal 5 square. 5 square means 25. So just multiply both sides by x minus 3 to solve this problem. If you multiply both sides by x minus 3, this x minus 3 is gone. On the left side you have 5x plus 2. On the right side you have 25x minus 75. Now to solve for x, we can just bring this x on the left side. So let me just subtract 25x and then just subtract 2. So that will give us negative 20x on the left side, and on the right side that will give you 77, negative 77. So if we just negative 20x, because negative 25 positive 5x is negative 20x. So if you divide both sides by negative 20, x would be 77 over 20. And that is definitely from this domain, that is definitely greater than 3. So we can accept we can take this answer. So x is greater than, x is equal to 77 over 20.